Hello learners, welcome to our Precalculus class. I am Mr. Moses Angelo Becerro, your virtual teacher for today. Get your pen and papers ready as we discuss new concepts about trigonometric functions. Our lesson aims to accomplish the following objectives. First, to determine the domain and range of different trigonometric functions. Second, graph the 6 trigonometric functions with its amplitude and period. And last, solve situational problems involving trigonometric functions. But first, let's have a short run-through with your previous lessons in connection with our new topic. We have angle, conversion of radius to degrees, vice versa, arc length, and area of a sector. Angle has 3 parts. We have the initial ray, the terminal ray, and the common vertex. An angle is in standard position if its vertex is at the origin of a rectangular coordinate system and its initial side lies along the positive x-axis. So we have many kinds of angle: acute angle, right angle, obtuse angle, straight angle. So an angle is said to be positive if its terminal ray is rotating counterclockwise, and negative if it's rotating clockwise. So you have there a negative angle. 2 angles are coterminal if and only if their degree measures differ by 360k, where k is an element of integer. Okay, let's find the coterminal angles. Assume the following angles are in standard position. Find the positive angle less than 360 degrees that is coterminal with each of the following. So you have first the 420 angle. So you just subtract 360 degrees. So we have 60 degrees answer. And also the second, we have negative 120 degrees. You just add 360 degrees. So we have an answer of 240 degrees. Okay, now let's convert from radian to degree and vice versa. So to convert radian to degree, you just multiply it by 180 degrees over pi. And to convert degree to radian, you just multiply it by pi over 180 degrees. So as an example, you have 75 degrees. And to convert to radians, you just multiply it by pi over 180 degrees. So we have 5 pi over 12. So also from radian to degrees, pi over 8. So we have 22 over 5 degrees. And degrees to radian, negative 270 degrees, you have negative 3 pi over 2. We have here arc length. So in a circle of radius r, the length s of an arc intercepted by a central angle with measure theta radians is given by s is equal to r theta. So that is from the theta over 2 pi times the circumference of a circle. So you have r theta. So as an example, we find the length of an arc of a circle with radius 10 meters that subtends a central angle of 30 degrees. So first, we convert the degree to radians. 30 degree times pi over 180, we have pi over 6 radians. And then plug it to the formula. S is equal to 10 times pi over 6. So we have 5 pi over 3 meters. We also have area of a sector. In a circle of radius r, the area A of a sector with a central angle measuring theta radians. So the area is equal to 1/2 r squared theta. That is from theta over 2 pi times the area, pi r squared. So you have 1/2 theta r squared. So as an example, we find the area of a sector of a circle with central angle 60 degrees if the radius of the circle is 3 meters. So first, we convert the degrees to radians. 60 degrees times pi over 180 is equal to pi over 3 radians. And then we plug it to the area formula, 1/2 times 3 squared times pi over 3. So we have 3 pi over 2 square meter. So I know you are familiar with trigonometric ratio using right triangle approach and using acronym SOHCAHTOA to get the 6 trigonometric functions. So for sine theta is equal to opposite over hypotenuse, Ka for cosine theta is equal to adjacent over hypotenuse, and TOA for tangent is equal to opposite over adjacent. So you have also the inverse of that function, which is a cosecant, secant, and cotangent. So now let's go to our main topic, which is the trigonometric functions of real numbers. So the following functions are defined for any real numbers presented by a directed arc on the unit circle. So sine s is equal to y, cosine s is equal to x, tangent s is equal to y over x, that is x is not equal to 0, and cosecant s is equal to 1 over y, secant s is equal to 1 over x, cotangent s is equal to x over y. Let's go study further. We have here a unit circle on x and y plane. So we have these points 1, 0, 0 and 1, negative 1, 0, and 0, negative 1. So in this unit circle, you have a radius of 1 because it is called a unit circle. And let's try to draw a line from the origin into this point of the circle. So we'll call this x and y point. And to know this point, we need this length, and also this length. We'll call this length y because it's lying on the y-axis, and this is length x because it's lying on the x-axis. So to know this point, we'll use the SOHCAHTOA. So sine theta is equal to opposite over hypotenuse. So y over 1. So sine theta now is equal to y. And cosine theta is equal to adjacent over hypotenuse. So adjacent over hypotenuse is x over 1. So cosine theta is equal to x. So now we confirm that sine theta is equal to y and cosine theta is equal to x. So now let's try to determine the exact coordinate in a given angle. So we have here an angle, given angle of 45 degrees. 45 degrees is also a pi over 4. In finding the coordinates, we need to know the length of that triangle. So we isolate that triangle and then let this length equal to C, B, and A. So now we use, by using Pythagorean theorem, A squared plus B squared is equal to C squared. We know that this is 45 degrees, this is 45 degrees. So this length A is equal to the length of B. So we now plug in A to B. So now this becomes A squared plus A squared is equal to C squared. So is equal to 2A squared is equal to C squared. And then we end up C is equal to square root of 2A. So now we can go for the coordinates of that point. Sine theta is equal to A over square root of 2A. And then simplify that is square root of 2 over 2. And cosine theta is also A over square root of 2A. And then that is also now square root of 2 over 2. So now we have the coordinate, the x and then y is equal to square root of 2 over 2. Now let's try to do another angle in quadrant 1. Let's say for example that is our point. And then we have a given angle of 30 degrees. And then to find out this length and that length, we need to isolate again that triangle. And then to know that length, we need to extend a line here and a line to make an equilateral triangle. So we put this as C length and A length. So this length, this length, this length are equal. So this A will become C over 2. And this length will be our missing. So using Pythagorean theorem, A squared plus B squared is equal to C squared. So C squared is equal to C squared c over 2 squared plus b squared. So now c squared is equal to c squared over 4 plus b squared. So simplifying that, we have b is equal to square root of 3c over 2. And now we can proceed to finding the point. So sine theta is equal to c over 2 over c. That is c over 2 is this one. And then over hypotenuse is this one. So sine theta is equal to 1/2 cosine theta. Adjacent is b, square root of 3c over 2 all over c. And then that is equal to square root of 3 over 2. Now we have the point in the unit circle, that point of 30 degrees or pi over 6 is equal to square root of 3 over 2, which is the x, and the y is equal to 1/2. So in the example, we were able to determine the two coordinates of special angle. So if we will do the process further, then we will have this kind of diagram showing the coordinates of quadrant 1, 2, 3, and 4. So take note also of the signs of every coordinate. Trigonometric functions can be graphed on a rectangular coordinate system by plotting the points whose coordinates belong to a function. So we begin with the graph of a sine function, that is y is equal to sine x. And we have here also the points. In the x is from 0 to 2 pi with corresponding values of y. So now let's try to plot the points on the graph. And then let's try to connect the dots. So the domain of sine function of y is equal to sine x. Domain is all real numbers from negative infinity to positive infinity, and the range is from negative 1 to positive 1. Next is the graph of cosine function. Y is equal to cosine x, and we have the coordinates. The x is from 0 to 2 pi, and then we plot the dots and also connect the dots. So the domain for cosine function y is equal to cosine x are all real numbers from negative infinity to positive infinity, and the range is from negative 1 to positive 1. How do we find the amplitude and period of a function? So for sine function, we have, if it is in this form, y is equal to a sine x, the amplitude would be just the absolute value of a. And the period is just 2 pi over the absolute value of b. So let's say if we have y is equal to 3 sine negative 2x, we have the amplitude of 3, and the period is equal to 2 pi over 2. That is now equal to pi. So same as here, you can find the amplitude and period. So the sine function and the cosine function is the same in finding the amplitude and the period. As an example, we graph a cosine function of y is equal to cosine 2 pi over 3x and determine the amplitude and period. So the amplitude is just 1 because you have here 1. B is equal to 2 pi over 3, that is this one. So you plug in the b, 2 pi over b, 2 pi over 2 pi over 3 is equal to 3. Now let's graph that function. And that is the y is equal to cosine 2 pi over 3x. Another trigonometric function, we have a tangent function. Y is equal to tangent x. We also have here the coordinates. from pi over 2 to pi over 2. Now let's try to plot the points. We have now the domain is all real numbers except multiples of pi over 2, because pi over 2 is the vertical asymptote and the range is all real numbers. Now the inverse of tangent, we have a cotangent function. Y is equal to cotangent x, and we have the points here from 0 to pi, and then we will try to graph that one. So the domain of cotangent function is all real numbers except multiples of pi. 0, negative pi, 2 pi, and multiples of pi are vertical asymptote of cotangent function. And the range is all real numbers. Next graph is the inverse of sine function, which is the cosecant function. So we'll try to graph the y is equal to cosecant x using the points here. X is 0 to 2 pi with corresponding y. So the domain of the function are all real numbers except the multiples of pi again, because pi is the asymptote of the function. And the range is from the negative infinity to negative 1 and 1 to positive infinity. So our next graph is the inverse of cosine function, which is the secant function. So we will try to graph the y is equal to secant x. It is from 0 to 2 pi. And we will try to graph this one. So the second function has a domain of all real numbers except multiples of pi, because the multiples of pi are the vertical asymptote of the second function, and the range is from negative infinity to negative 1 and from 1 to positive infinity. So let's apply what we have learned in the trigonometric functions. Let's take a look at the application problem. Suppose that a population of a certain predator at a time t in months is given. A region is estimated to be a function of pt is equal to 10,000 plus 3,000 sine 2 pi t over 24. And the population of its primary food source, which is the prey, is estimated to be a function of small pt is equal to 15,000 plus 5,000 cosine 2 pi t over 24. So sketch both of the functions on the same graph and explain the oscillations in the size of each population. As you can see, this sample is related to biology science class about predation on feeding behavior of organisms. Now let's try to solve the problem. We get the period by plugging the 2 pi over 4 to the formula 2 pi over absolute value of b. We have 24 months. So the two functions have 24 months of period, and then we graph the function. So the blue one is for the prey and the red graph is for the predator. So they both have 24 months of period. So the graph shows the relationship between the predator's prey. If the predator population increases, the prey population decreases. And when the predator population decreases, the prey population increases. So try to look at this on the graph. The red one here,
as the predator increases, the population of the prey decreases. And when the population of the prey decreases, the population of predator also decreases. And that's the time the population of prey increases when the predator population decreases. And then that cycle goes on repeatedly. So today we learned how to sketch, determine the domain and range, amplitude, period, and solve problems relating to trigonometric functions. And I hope you enjoyed the session as much as I do. Always remember, mathematics is a skill. It requires patience, perseverance, and a lot of practice. Bye everyone, keep safe, and see you next time. Bye-bye!